Hello there, ROS developers, and welcome to a new open class. Today we are going to be talking about ROS2, and more specifically, we are going to be talking about debugging tools in ROS2. So we are going to see a couple of very interesting debugging tools that can be used in ROS2. So yeah, welcome everybody. And let's get started. So first of all, as always, let me know if the chat is good, the image is good, so that we can keep going without any issue. And then, yeah, let me right now move to the computer screen. There we go. So yeah, let me log in and go to the live class page. Yeah, let's go through here so that I can see the chat. Okay, there we go. Looks good. I can hear and see you well. Hello. All right. Okay, so everything seems to be working properly. Then let's get started. So I don't know if you are new into these open classes, if you have already some previous experience. In any case, always that we are going to start an open class, the first thing to do is to get the class rosject. Okay, how can you do this? Very easily. All you have to do is to click here in this button that you have right above the chat, which says fork, and open the class rosject. All right, so I'm going to click into this button myself, so all of you can do the same. And then basically this is going to do a couple of things. First of all, it's going to generate a copy of this rosject into your account. Okay, so you're going to have this rosject forever into your account. So not only during this class, but forever. You can go back and open it tomorrow, next week, next month, whenever you want. All right, and also, as you can see, it's going to automatically bring you here to the main rosject page, which is the one that I am here. It's still loading. It might take some seconds to fully load everything. There it goes. Then once it is loaded, you are going to be able to see here the Jupyter notebook. Yeah, there you go. So here we have the notebook for today's class. We are in open class number 158. And here in the notebook is where you are going to find all the instructions, exercises, code, commands that we are going to be executing and doing during today's class. All right. Then yeah, so here at the right side also you have the streaming panel with the chat, the live video right here, so that you can follow what I am doing. Also you have the chat in case that you have questions, you have any issue, you can type here, and I will try to answer everything. All right. So first thing first, let me know, have you been able to launch the rosject? Yes, no? Are you in the same page as I am here with the rosject loaded, the notebook opened, and ready to start with the class? Yes, say Song, also Masiesh, also Janak, okay. Perfect. Then the first thing that we are going to do is to start a simulation, okay? So we are going to start a gazebo simulation based in ROS2. And in order to do this, we are going to run this command, all right? Then the first thing we have to do is to open a terminal, a shell. Yeah. Then you can do this very easily by clicking on this icon here, as you have here indicated in the notebook. The first icon that you have here in the bottom menu. Yeah. If you click here, this is going to open a brand new terminal. Okay. Now in this terminal, you can of course write commands, and in this case, the one that we are going to run is this one. All right. So let's select this command here from the notebook. You can select it here in the notebook, copy it, and paste it directly here into the shell, okay? And then run it, okay? Then this is going to start the gazebo simulation. Don't worry if you see here some red messages and even some errors, okay? Don't worry, you can just ignore it. they are normal. The simulation should work still. See? So at the end, you are going to have the gazebo simulation loaded, like I have here. You can see here the environment with the robot, which is an MP400 robot from Robotics. Yeah. It might happen in some cases that gazebo gets stuck and doesn't fully load. Okay, or maybe in some cases also it can happen that you can see the world, but the robot is not there. Okay, if you are getting some of these strange errors, don't worry. All you have to do is to stop the program. Okay, stop the command here with Control-C. Okay, just stop it and relaunch it. Okay. If the first time it doesn't load properly, just stop it and relaunch it, and very likely the second time it's going to work properly, okay? There are sometimes issues with gazebo on this, so yeah. You are going to know that everything went okay when you get something like this, yeah? You can see the world and the robot here in the middle, okay? Yeah, so far so good. Have you been able to start the simulation? There. Okay, Volker says after the second time, yes. Okay. Also song after second time, also Masiesh. Okay, perfect. It's loading very slowly, says Janek. Okay, let's give it some seconds. And if you see that after some seconds it doesn't load, just stop it with Control-C and relaunch it. Okay, Janek? All right. Then, okay, so now we are going to leave, yeah, robot missing. Okay, then just stop it with Control-C, okay, and relaunch and execute again the command. Okay, Janek? Yep. The second time it's going to work. All right, then we are going to leave this shell here running, okay? Because we want to have the simulation running. Yeah, if we close this shell, the simulation is going to die. So we are going to leave this one here running, and then we are going to open another one, which we are going to use to work. Okay. We can rename the first one, this one, to simulation if you want, sim, something like this, so that we know that here in the first one we have the simulation running and we don't want to close it. Then we are going to start. We are going to see a couple of debugging tools that we can use in ROS2. First one are the debugging messages. Okay, we are going to start by having a look at how to use ROS2 debugging messages and different log levels. And later we will have a look also at ROS2, okay? And how to work a little bit with ROS2, which is probably the most important debugging tool in ROS2, okay? Then, yeah. As for debugging messages, you have to understand, first of all, that there exist different log levels, let's say, or error levels, okay? Basically, we have these 5 levels. We have the debug level, okay, which is the lightest one, let's say. Then we have info, warning, error, and fatal, okay? As you can see, each one is worse than the previous one, yeah? So debug messages are just for debugging things. They don't have to be indicating anything bad. Same as for info. Warnings can indicate something that has to be taken into account, but it's not necessarily an error. Yeah. Then you have the next level, which is error, for actual errors, and fatal, which is, as you may already know, a fatal error. So if we see a fatal error message, probably something bad is happening with our program, okay? Then we have different error levels for indicating different things, yeah? So in order to add debug messages into our code, we don't just have to indicate errors. Yeah, we can add debug messages which indicate something which is not an error. Yeah, in that case, then we can use the debug level, info level, even warning level. Okay, so this is important to know. Then, how can we make use of the ROS2 debugging messages in our ROS2 programs? Okay, so we are going to see an example, as we always like to do in the construct, by practicing, okay? Then we are going to start by creating a new package named logs test, okay? Then let's go with that. So let's go to the ROS2 workspace, okay? Here in home user ROS2 workspace, of course, inside the src folder, yeah? When we want to create new packages, we have to be inside the src folder, right? Then here we are going to create a new package. So ROS2 package create. We are going to set it as a Python package. And how do we do this? Well, by defining the build type as amend Python. Okay? If we set the build type to amend Python, this is going to generate a Python package. Okay? Then ROS2 package create. There we go. And finally, we are going to add as dependencies rclpy. Yeah, this is the Python client library for ROS2, so that we can create Python scripts for ROS2. Yeah. So ROS2 package create, build type, amend Python, and as dependencies, we add rclpy, which is the Python client library for ROS2. All right? Then, yeah, so let's execute this command. And there's something wrong here. Oh, of course. Here it says error. The following arguments are required. Package name. Yeah, so I forgot to give a name to the package, right? So I can add it here. It was logs test, right? Yeah. So here in the exercise it says to create a new package named logs test. There we go. So we add the package name and we run it, and now it should work. There we go. And if we have a look here, we can see our new package, all right? Also, I'm going to open at this point the code editor, which is the second icon that you have here in the bottom menu, yeah? So I'm going to click here in order to open the code editor, which is going to allow me to visualize with a graphical interface all the folders that I have here in the rosject. Then, for instance, if I go here inside the ROS2 workspace and inside the src folder, I'm going to find here the new package that I have just created, right? Logs test. Okay. So what else are we going to do? Then inside this package, we are going to create a new Python script named loggerexample.py. And inside this file, copy the code shown below, the code that we have here, okay? Then, Janak says, does call consider work in this system? Not by default, Janak. By default, it's not set up. So if you want to use it, you will need to set it up. Then, okay, yeah, then let's create our new Python script. So remember, yeah, as for Python scripts, you are going to place them here inside the logs test folder, okay? The folder where you have the init py file. So here, let's create our logger example.py, yeah? Okay, and then inside here, we are just going to copy the code that you can find here in the notebook, copy it and paste it into the file. Okay? There we go. All right, then let's have a quick look here at our code. Okay? It's very simple, as you are going to see. So we are importing Node, yeah? because we are creating a class here named logDemo, which inherits from node. Yeah, most of the nodes that you create for ROS2 are going to inherit from the node parent class. Okay. Also in RCL CPP, it's the same. Then in our class we have the constructor where we initiate here a node named logger example. Okay. And then we are using this line, yeah, so we are accessing to the logging element of RCLPy, and we are we are calling this set logger level method. Okay, this method allows you to set the logger level of this node. Yeah. Then in this case we are setting the logger level of the logger example node, right? And we are setting the logger level to debug. Okay? What does this mean? This means if we set the so this means that our node is going to print all the log messages which are on the debug level and above. Yeah, so we can go back here to this image that we have. Yeah, so if we set the logging level to debug, my node is going to print all the log messages, including the debug level and below. So debug, info, warning, error, and fatal. Okay. What does this mean? This means that if we set the logger level of my node, of your node, to warning, for instance, and your node contains logs on the debug and the info level, these are not going to be printed. Okay, we are going to see this in a moment in practice. Yeah. Why is the initpy file created by default? This isn't the case for the building system is completely different in ROS2 than in ROS1. All right, Janak. So in ROS1, actually, you cannot. So all the packages, you don't have a specific Python type of package in ROS1. Yeah. So in ROS2, the building system is different for Python, which is our case, and for C++ or CMake. So it's not comparable with ROS1 in this case. All right, then. What else? Yeah, so we were setting the logging severity, yeah, to debug. Then what else? We are creating a timer here, which is going to be executed every 0.2 seconds, and with this timer callback method. And inside the timer callback method, I am printing different log messages. See, as you can see, in order to access the debug messages, we do it from, we have to run this get logger method, yeah, from self. So from my node, yeah, I get the logger of my node, and then I print a message, a debug message, which is on the info level, yeah. Here I am printing one on the info level, on the debug level, on the warning level, on the error level, and on the fatal level. Yeah, so I am printing one debug message on each level, as you can see. Okay? And then in the main function, so we just create an instance of the class and we spin the node until I want to specifically terminate it. Okay, then let's compile this, which, as you can see, it's a super simple example. Then, well, first of all, we are going to create a launch file, okay, to run this. So inside the logs test package, let me create a new folder, launch. And inside this launch folder, let me create a new launch file, which I'm going to name as logger example.launch.py. Okay. Now here, you can come down here to the solutions section in the notebook, and I'm going to copy from here the launch file, There we go. Yeah, very simple launch file. We specify the package, which is logs-test, the executable node, which is logger example node, and the output to the screen, okay? Now, in order to generate this executable, I need to do some additional modifications to setup.py, okay? All this, I'm not explaining all this because it's not the purpose of this class, yes? All this is let's say, basics of creating a package and compiling and so on, which is not the purpose of this class. This class, we want to focus on ROS2 debugging tools, right? But all this, you can learn about all these steps more in detail if you want. Here at the end of the notebook, I have left here a link to the ROS2 basics in 5 days course, yeah, where all of this is explained in much more detail. Yeah, but I will come back to this later. Then let's go back. So I have created the launch file, and then I have to do some modifications to the setup.py file in order to properly compile. So first of all, if you want, you can copy directly the setup.py file from here and paste it here, okay? I'm not going to do it because I know what I am doing, so I know which lines I need specifically, which are these 2 imports. I'm going to add them right here at the top. Then I also need to add this line here. Yeah, here in the data files, I need to add this line, which is going to install all the launch files into my workspace, okay? This is so that this launch file is installed in my workspace, so that I can actually use it and the ROS2 system can find it, okay? And then finally, here in the entry points is where I'm going to define my executable. Yeah, so let me copy this line here and paste it here. Yeah, so here what I am doing is to generate an executable named like this, logger example node, and this executable is going to be generated from the main function. Yeah, from the main function of the logger example Python script, which is this one here. Oops. Know what I did. Sorry. Let me refresh it. Yeah, there we go. There we go. Setup. Yeah, from the main function of the logger example Python script, which is inside the logs test package. Yeah, so this is package name. Well, this is executable name that I want to generate. Then this is package name, this is Python script name, and this is function name. Okay? And that's it. So now I'm ready to compile. So let me come here to back to the terminal, okay? And then remember that always for building, you need to be in the root of the workspace, yeah? So for creating the package, all the packages are going to be contained inside the SRC folder, yeah? But for building your workspace, you need to be in the root, which is here, home user ROS2 workspace. Now I can build my package with call build, and I can specify the name so that I only build my package, which is logs test. Yeah? With this flag, packages select, I can specify the name of the package that I want to build. Yeah, which in this case is logs test. So let me run the command and build my package. There we go, it's done, okay? Now, after compiling, it's important to always source the workspace. There we go. And then I can run my program, right? So let's execute it with ROS2 launch. Specify the name of the package, which is logs test. And then the name of the launch file, which is logger example.launch.py. There we go. And now if I execute it, I should start seeing all the different log messages. Yeah, here I have them. Let me stop it so that we can have a look. Yeah, if you see here, you can see all the messages with the info, debug, warning, error, and fatal. See? Info, debug, warning, error, and fatal. All the messages that I am printing, you can verify here that all the messages here are being printed. Yeah? Now, there is one interesting thing that I want to show you before this, because like this, okay, yeah, so you can see which type of message is each one of them, because it's indicated here, yeah? So this one is an info message, this is a debug message, this is a warning message, this is an error message, and this is a fatal message, right? But there is an interesting trick that you can use to make this more clear, yeah? And this is to specify in the launch file here, yeah, you can specify, let's add something down here. Let's add an extra option, yeah, which is emulate underscore TTY. And this, we are going to set it to true. Okay? So after the output, I have specified another argument here, emulate TTI equals to true. Okay, let me put it here in the chat, in case that you want to copy it, something. Okay, and what does this extra argument do? We are going to see it in a moment. So let me recompile. Yeah, let me recompile my package again, so that this change that I have added gets taken into account. Then source, and now I'm going to execute again my program, yeah? And you're going to see a small difference. Okay, see? So now, the different levels of the debugging messages have different colors. See, let me stop it a moment, yeah? So the info messages are shown in white, debug messages are shown in green, warning messages are shown in yellow, and both error and fatal messages are shown in red. Yeah. So this is helpful in a visual way, because you can very clearly differentiate between the different messages which have different log levels. Okay. Yeah. So far so good. Have you been able to reproduce this first demonstration? Have you created the package, the program? And you can see all the different log messages being printed here. Yes, no? Masiesh says, yes, everything is okay. I have got colorful terminal. Okay, perfect. It looks better like this, right? In my opinion, I prefer this than having all the messages in white, because you can very clearly spot, for instance, error messages, right? Editor not starting, just listening today, says Volker. Okay, that is strange. Can you try to maybe click here in the reload button, Volker? Or close it and open it again? Clicking here in reload. Even maybe clicking here in to move it to a new tab. Maybe that can help. This second button here, which is open in a new browser, this is going to bring it to a different tab. Maybe doing it like this, it works. I don't know, just suggesting things. Okay, that is strange. That is strange then, Volker. Retrons cannot find the launch file. So Janak cannot find Cannot find the launch file. Okay, so have you created, let me open my code editor again. Oh, so you don't have the .py at the end? Yeah, it's like CET says. Yeah, the launch file is a Python script. So it has to have the Python extension at the end. See? Logger example.launch.py. In fact, this is a Python function. Yeah? Then you have to add the .py at the end. This is one thing. And then second thing is that you need to add this line to your setup.py. Yeah, inside the data files, you need to also have this line here. Yeah, because this is going to actually install the launch files that you have inside here. It's going to install them into your workspace so that ROS2 can find them. Yeah, if you don't have this line, then ROS2 is not going to find the launch file. Or if you have this line, but the extension is wrong. Yeah, because this is going to basically install all the launch files that end with .launch.py. So if your file is only .launch, it's not going to install it, right? So it's not going to work. Okay, looking into it very well. It's a very good trick, says Diego. Yeah. Definitely better. Do I have to give? No, not necessary to give right permissions. All right, then here, yeah, so now we have here another exercise, which is very, very simple, so we can do it in a moment. Then here, as you can see right now, we can see all the messages, right? We can see messages from the info level, debug level, warning level, error level, and fatal. So all the 5 different severity levels, right? Why is this? Why can we see all the messages? Can somebody tell me? Why? Because we've got debug level. Okay, that's right. Yeah. So in our Python script, right, we set here in line 10, we are setting our logger level to debug, right? So if I only want to see, I don't care about the debug and info messages, okay? I only want to see warning messages and above, because these are the ones that are more dangerous, right, for the program. So I want to see only warning messages and above. What do I have to set here? Which debugging level, which severity level should I set in my program? I don't care about, we need to change debug to warning. Okay, perfect. Actually, it's not warning, but warn, okay? Warning, it's not going to warn. It's not going to work. You have to set warn, okay? Then, but the answer is correct. So now, let me see what happens. Let me recompile my code here. Source again and run my program one more time. And now I am filtering the log messages, right? And I can only, now my program is only displaying the warning, error, and fatal log messages. Yeah? All right. And you can do this with all the levels, of course. Yeah. So this is very interesting because you can add many messages. Yeah. So you can add many messages to your program. Different messages for debugging, for info, for warning, error, fatal. You can add as many messages as you want because later on runtime, yeah, when you execute it, you are going to be able to filter. Yeah. So you don't have to necessarily visualize all the log messages. Yeah. So you can filter your program so that you only visualize the one that are interesting for you at that moment. Okay? All right. Then let's continue with RVs. Yeah? So probably all of you already know about RVs, yeah, because it's a very it's an awesome tool also for ROS1, yeah, and actually the ROS2, which is the ROS2 version, is very similar to RVs for ROS1. Okay, then it's very important to understand one thing, yeah. So RVs is only a visualization tool. Yeah. So what you do in RVs is to let's say visualize what the robot is seeing or what the robot is sensing, what the robot is perceiving. Okay. So because I have seen while teaching ROS and ROS2 that a lot of people misunderstand what RVs is, and they think that RVs is a simulation on its own. No. So RVs is only a visualization tool. Yeah, and of course it's a tool that can be used, and it's extremely helpful for debugging issues, both in simulation and in real robots. Right? Then let's try to analyze a little bit our simulation, the simulation that we have right now using RVs, okay? We are going to do a basic configuration. Then, in order to start it, you can run ROS2 in a terminal, for instance, here. Yeah, in this one, let's execute the ROS2 command, okay? And this is going to open here the graphical tools where we can, see RVs. All right, let's put it here. Then I suggest you double click here, you maximize this to optimize the space. Okay. Then the first thing that we are going to do here is to visualize the robot frames. Okay, I want to know what are the frames of my robot. Yeah. How can I do this? Does somebody know? I want to quickly visualize the different frames of my robot. How can I do this? Very easily, using ROS2. TF. Okay, very well. So let's add a new display. Yeah, in order to add displays in ROS2, you have to click here in the Add button. All right, and the displays are going to shown here in the left menu. So let's click on the Add button, and then we can scroll down and look for the TF display. Okay. All right. So I have added the TF display here. Okay, and I can see actually nothing. Yeah. We can open here the frames. Yeah. And we can see some frames here. Yeah. But actually in RVs, I cannot visualize anything, right? And this is because I have something configured wrong in my RVs. Does somebody know what it is? What do I need to change here? What is wrong in my ROS2 current configuration? The fixed frame, very well. Okay. Okay, yeah. So the fixed frame is going to set the frame from which I'm going to visualize things. All right? Then in this case, in my simulation, yeah, this map frame that I have here by default doesn't exist. Yeah, this map frame is used especially in navigation. Yeah, in systems which have autonomous navigation, you always have this map frame. You use this map frame for publishing the map and sending goals to your robot with reference to that map and so on. Okay. In this case, we don't have a navigation system running, so we don't have this map frame. So what I'm going to do is to change it and set it to base link. Okay? And now, suddenly, here, all my frames appear. Okay? You can, if you want, check here the show names. Inside the TF display configuration, you can check the show names, and then this is going to show all the names of the different frames, okay? I'm going to take it out, and then also inside the frames, you can set to all enabled, non-enabled, and you can select and unselect only the ones that are interesting for you, okay? For instance, I'm going to leave here, I don't know, base link, and ODOM, for instance. Yeah, here we can see that right now, baselink and ODOM are the same frame, yeah? But this is going to change as soon as I start moving the robot, for instance. Or I can see also the relation between the baselink frame and the laser frame, yeah? Here I can see the relation, yeah? And this arrow that you can see here, which goes from one frame to another, represents the TF, the transform, from the LiDAR 1 link frame to the base link frame. And this is very important in a robotic system, okay? Very, very important. All right, then let's visualize more things. So let me go back to the notebook, because actually I am doing a little bit of freestyle, but everything that I am doing here is explained a little bit more in detail in the notebook, okay? So you can check it later if you want. Then another thing that we can add is the robot model, okay? So we can visualize the frames like this, and this is interesting. But let me actually enable all of them and take out the names, okay? But also it can be nice to actually be able to visualize the robot model, right? So let's add another display. And here, from the different options, we are going to select, in this case, robot model, okay? Then click on OK. And now, here, in order to visualize the robot model, you have basically two modes, okay? In ROS2. And you can define them here in the description source. Yeah, so you can see right now here that by default is set to topic. We are going to change it to file right now, okay? Then if you set the description source to file, you have to, of course, specify this file, yeah? And what is the file that defines a robot model? It's the URDF file, right? Then we can come here, URDF, yeah, and click on the buttons, and then here we can go inside Robotics ROS2, Neo Simulation 2, Robots, NP400, and then select here NP_400 URDF, okay? You have, and click on open, okay? You have the full path here also indicated in the notebook, okay? So don't worry. Yeah? And what does this do? This allows you to actually visualize the robot model, yeah? So you don't just see a bunch of frames there, but you can actually see the model, yeah? And you can, as always, you can configure each display with many different things. For instance, the robot model, you can modify the alpha to make it a little bit more transparent. See? So that you can see the robot model, but you can see also the frames, etc. Okay? Or even more, yeah? Then let's leave it like this in our case. All right? Then this is one option to visualize the robot model, but it's not the only one, of course. Yeah. So let me take out this one. Well, actually, we can just change this. Yeah. So I'm going to change. Now we are going to change the description source to topic. Yeah. Now, instead of a file, I want to get my robot model from a topic. Yeah. And the topic that contains the robot model, usually, it's almost always it's going to be the same topic. Yeah, it's a well-known topic. Does somebody know which topic is the one that contains the robot model information? All the URDF information, let's say. Yes, no? Okay, so usually the information of the URDF, it's going to be published into a topic which is known as robot_description. Okay? So let's set the topic to robot description, hit enter. And again, we have the robot. Okay? So you have the two options. Okay? I would say that usually the correct one would be to use the topic configuration. Okay? But in some cases, it might be helpful also to use the file configuration. Okay? Robot description, says Arnaud. Very well. Yeah. So all the information of the robot, the URDF, basically the contents of the URDF are published into this robot description topic by the robot state publisher. Okay. And then let's visualize. Let's add one last display. Okay. Because so far we are seeing the robot model, we are seeing the frames of the robot. But what about the sensors? Yeah, because this is one of the most important and most interesting things that you can do in RVs, is to visualize, actually, get information from the sensors of the robot. Yeah. In this case, I'm going to add a display to visualize the laser readings of the robot. Okay. So this MP400 robot contains laser information, as you can see here in Gazebo. Yeah. It contains a laser. And we can visualize this laser data in RVs. And in order to do this, you have to add a display, which is the laser scan display. You have it here, okay? So let's add this one. Janak says, when would you want to use the file? The URDF needs to be loaded anyways to see the TF, right? Then why not just use the robot description topic? Yeah. So usually you want to use the robot description topic. Yeah, but you are going to, in some cases, in my experience, I have found some simulations that don't have this robot description topic. Okay. Or it doesn't work properly so that it can be visualized in RVs. Okay. And in that cases, then if you want to visualize the robot, you have to directly load the file, and that's it. Yeah, but ideally, you are going to use the topic. Yeah. So the file is going to be just for cases in which you are working with a simulation that doesn't have the robot description topic published properly, or it doesn't work properly, things like this. Yeah, but for all the cases, all the majority of the cases, you are going to want to use the topic. Yeah, because every simulation should have the robot description topic published. Yeah. Then, okay, so as for the laser scan, let's try to visualize now the data, because right now we have added this, but we cannot see anything, right, yet. Then the first thing we have to specify, of course, is the topic. Yeah. So we need to specify the topic where my robot is publishing this data, right? Usually this topic is going to be named scan something, yeah? So we can run a ROS2 topic list here. ROS2 topic list, yeah? And in order to get a list of all the topics, and from all of these, yeah, we can identify that the one which contains the laser data probably is going to be scan, right? So let's come here to the topic and select. Actually, by default, as you can see, if you click here, it's going to show you actually the topics that contain laser scan messages. Yeah, by default. So we can select it from here and hit enter. And still, I cannot see anything. Then, why I cannot see anything? Does somebody know what could be the problem? Without reading from the notebook, please. Objects are too far from the robot. That's a possibility, Masiesh. That's a very good. That's a very good answer. Yeah, it could be that the objects are too far from the robot and the laser cannot detect them. Okay, this is not the case. Okay, the range of the laser is I believe it's like 30 meter, something like this. Yeah, and we can see here in the Gazebo client that actually the laser beams, these blue things that you have here in the simulation, represent the laser beams. Yeah, so you can see that they are finding objects. So they are colliding here with this sphere, right? They are colliding here with these walls. So actually, there are obstacles close enough so that the laser can detect them. Yeah, but what you said, it could be a possibility. Yeah. So if the objects were too far away from the laser range, then obviously we wouldn't see anything in RVs. But here in this case, the problem is another. The problem is related to what is known in ROS2 as the quality of service. Yeah. So each topic has special settings which are known as quality of service. Okay, which define different behaviors of the topic, okay, of how the information is transported through this topic. Then every topic has a specific quality of service configuration, okay? Then if you want to be able to visualize the data from this topic, you need to configure the subscriber. In this case, the subscriber is service. You need to configure the subscriber quality of service with a configuration that is compatible with the publisher. Yeah? Do you understand? Does this make sense? Then how can you check, for instance, a quick way to see the quality of service settings of the scan topic is to run the following command: ROS2 topic info scan and add the -v flag for verbose. Yeah. Then if you run this command, this is going to show you all the information related to the topic. Then if we come here to the publisher, we are going to see here the QoS profile. Yeah. So this indicates that the reliability is configured to best effort and the durability is configured to volatile, okay? Then in RVs, here, let me make this bigger. You can come here to the topic configuration, and you are going to see the QoS configurations, which are the depth, history policy, reliability, and durability. Okay? In this case, as you can see, here I have the reliability policy set to reliable. But if I check my topic, I can see that the reliability policy is set to best effort. Yeah? Then if I change here in RVs the reliability policy to best effort, suddenly I start getting the laser readings. See? You can change here the size to see them better, because like this they are very small. But you can make the size, yeah? And now we can see here the readings, yeah? You can see here right in front of the robot the sphere, yeah, that is being detected, this sphere, and then the walls also, you can see them here in RVs, right? So the QoS configuration is very important in RVs, yeah? It can happen sometimes that you don't visualize something, and you might think that there is a problem, there is an error, there is something, but it's just that your QoS configuration is not correct. It doesn't match the it doesn't match the configuration of the topic that you want to visualize, right? So this is something to take into account when working with ROS2. All right? And yeah, and basically that's it. So that's it. Here at the end, I think that we have a command to start moving the robot and see how the laser readings change and so on. We can run it if you want here. Yeah. So this is going to start moving the robot here. This command, right? And then of course we are going to see how the laser readings are changing. Also, you can see the odom frame here. Yeah, this is the odom frame. If I show the names, yeah. And yeah, so of course, as you move the robot and you do things with the robot, all this is going to be updated in RVs. Yeah, because at the end, what RVs shows is how your robot senses the environment, how your robot perceives the environment. Okay? And yeah, that's it. So we are just in time in order to leave it here. Then yeah, so we have visualized two very interesting debugging tools, I think. These two debugging tools, you can start using them from the beginning. They are going to be very useful for creating your ROS2 programs, for debugging things related to the robot, etc., etc. Yeah. And yeah, then just at the end, just want to remind you that I have left you here the link, as always, at the end of the notebook. You can click here, and this is going to bring you to the new course that we have published, which is the ROS2 Basics in 5 days. Version for Python and Galactic, yeah? So we already had this course in the academy, but it was for Foxy. So now we have fully updated the course for Galactic, yeah? And in the future, of course, we are going to keep updating it to Humble and so on, yeah? But so far, this week we have published the update to Galactic. And in this course, you are going to find of course, a unit talking about ROS2 debugging tools with many more things than this. Yeah, you are going to be able to see in the course other debugging tools which are very, very interesting, like ROS2 Doctor, and of course many other things, from the very basics on how to creating a ROS2 package and how to create a very simple ROS2 node, to creating much more complex programs using services, actions, and so on. Yeah. So in this course, you are going to learn basically all the essentials that you need to learn related to ROS2. And that's it. Yeah. So Interesting, the importance of QoS to see data in RVs. Yeah. This is something that it's new to ROS2, all these QoS settings. So yeah, it's something to bear in mind when working with ROS2, for sure. Then, yeah, so before closing, let me activate here the rate form so that we can quickly, you can quickly give us some feedback related to this open class. Let me activate it right now. It should appear in some seconds here in the chat. 1, 2, 3. Yeah. So you're going to have this form so that you can give some feedback if you like the class, if not. All right. Volker is asking, any reason why Galactic not Humble? No. So we are still waiting a little bit to do the update to Humble, but we are going to do it very pretty soon. Yeah. So we are going to be updating all our ROS2 courses to Humble pretty soon. Yeah. Especially because it's a long-term service distribution, unlike Galactic. Yeah. But we are going to have them in Galactic, in Humble very soon, Volker. So it's not that we choose Galactic over Humble, yeah, but it's just a previous step. How did you get the ROS2 logs to print with the colors? Yeah, so it's with this argument in the launch file. Yeah, you add this argument, emulate_tty. Yeah, let me copy it again here. Yeah, you have to add this argument, emulate_tty, to true. And then you're going to visualize the logs with the colors in the shell. Okay. All right, then let's leave it here. Thanks a lot to all of you for attending this open class. I hope that you liked it. I hope that you have learned something new. And yeah, I will see you again in the next one. And until then, as always, keep pushing your ROS learning. Bye-bye.